Hello, it's Dumplet here. Here's an item on summations. Evaluate 1 squared over 1 times 3, plus 2 squared over 3 times 5, plus so on and so forth until 10 squared over 19 times 21. Now credits to the Art of Problem Solving community for this question. As usual, pause this video if you'd like to give this item a try, but if you're done, let us dive into the solution. Now, whenever we see an item like this one of the nice techniques that we might be able to use is to see if there will be a nice format. Well, there must be a pattern, but what's the format of the pattern, or like a general term of the sequence? And usually we want to see if it telescopes or not, or maybe some of the terms is going to cancel out. So those are the type of observations we make. Now let's try to observe the general term, like the nth term of the sequence. We can kind of see that the nth term of the sequence is of the form n squared divided by 2n minus 1 times 2n plus 1. And that's just by observing that we have like a pattern in the numerator. So it's just the square of 1, 2, 3 all the way until 10. And then in the denominator, it's like consecutive odd numbers. So we can write it in this format. But then again, you always want to compare and contrast the terms here in the given sum to make sure that you have like the correct general term. So the nth term of the sum is just this. So essentially, we're just taking the summation of this thing from n equals 1, which is going to be the first term, up to n equals 10, which is going to be the 10th term. Now, we're going to dive into this form, again, because we want to make sure, we want to try to see if there is going to be like a nice way for us to view this term. Now, multiplying out the denominator, it's going to be n squared over 4n squared minus 1. Now, we can't do partial fractions or to decompose into partial fractions yet, because we have an n squared in the numerator. So let's try to see what we can do with that. Now, I'm going to do some manipulation here because I kind of want to remove that n squared. Now, I'm going to remove the n squared by first multiplying it by 1/4 of 4n squared. Now, as you can see here, if I ignore the second part here, it's going to be the same. So n squared over 4n squared minus 1 is just the same as 1/4 of 4n squared over 4n squared minus 1. And the reason why I included this minus 1 and then added 1 to it seems pretty dumb. But the reason why I did that is because I get to cancel this part into just 1. So this part is going to be the 4n squared minus 1 over 4n squared minus 1. And then the remaining part is just the 1 over 4n squared minus 1. So this is just the same as 1 plus 1 over 4n squared minus 1, which kind of helps us here because we successfully removed the n squared, which was a problem before we can do our partial fractions. Now, we have 1 plus 1 over 4n squared minus 1, and this is very easy now to do the partial fractions because this is just simply equal to 1/2 times 1 over n squared minus, 1 over 2n minus 1 minus 1 over 2n plus 1. Now that's because the factored form of this, it's going to be, as you can see in the general term a while ago, it was just equal to this one. So we would be able to get a nice partial fraction here. So just 1/2 of 1 over 2n minus 1 minus 1 over 2n plus 1. So this will be step 1 before we do our telescoping series. Now, let's try to expand on this a little bit so we can kind of work on it a little bit better. So the original thing, the n squared over 4n squared minus 1, the general term, the nth term, it's going to be equal to this thing, 1/4 plus 1/8 times 1 over 2n minus 1 minus 1 over 2n plus 1. And essentially, this thing is just the n squared over 4n squared minus 1. So we're taking this thing, so the summation of this from n equals 1 to 10. Now let's try to work on this one because all we have to do is just make sure that we put the right thing, make the right substitutions. All right, the 1/4 becomes 10 over 4. I guess it makes sense because we're just adding 1/4 from n equals 1 to n equals 10. That's 10 times. So 10 times 1/4, that's just 10 fourths. And then we have the 1/8 times 1 over 2n minus 1 times, 1 over 2n minus 1 minus 1 over 2n plus 1. Now if n equals 1, it's going to give me the 1 over 1 minus 1 over 3, which is going to be this one. So this is the term when n equals 1, with the 1/8 outside. Now I'm going to factor that out because, I mean, it is a common factor to all the terms. And then the 1/3 minus 1/5, that comes from the n equals 2 part. And then we're doing this all the way until the last term, where the n equals 10 part is going to come. Now, this is a very famous example of a telescoping series because everything in between gets cancelled out. For example, this minus 1/3 gets cancelled with the plus 1/3, and this minus 1/5 gets cancelled with this term, which is the next term, which is going to have this 1/5 minus 1/7. So we can expect the minus 1/5 to be cancelled with the 1/5 in the ellipsis, hidden 1/5 in the ellipsis. And then this 1/19, now remember that there is a term 1/17 minus 1/19 in the ellipsis. So the 1/19, it's going to get cancelled with the minus 1/19 here in the ellipsis part. And that's the reason why we have a telescoping series, because everything in the middle gets cancelled. So what remains is just the following. So the 10/4, we can write it as 5/2 in lowest term, and then plus 1/8. And then whatever remains in the parenthesis is just 1 minus 1/21. Now we can do some simplifications here. 1 minus 1/21, that's going to be equal to 20/21. Then we can make some nice cancellations here. The 8 and the 20 cancels nicely. That's going to be equal to 5/2 times 21. That's going to be equal to 5/42. Now the last step is just to do this. So 5/2 plus 5/42. Write it into one fraction. It's going to be 105 plus 5/42. Now this is going to be equal to 110 divided by 42. And then writing it in lowest term, we're going to get 55/21 as the summation in the beginning. And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!